Today, I'm your chemistry teacher Aparna Shrivastava. Today we will discuss again this chapter, general principle and process of isolation of element. Earlier we have discussed ore, crushing and grinding, concentration, the part of concentration, gravity separation method, magnetic separation method, fourth flotation, leaching, roasting and calcination. So today we will study reduction. One by one we'll discuss reduction. So reduction, the main part of reduction by carbon, reduction by electrolysis, reduction by CO means carbon monoxide, reduction by aluminum, reduction by heat alone. Okay, one by one we will discuss. First we will study reduction by carbon. Okay, now we know that the carbon in the form of coke or coal is the cheapest reducing agent. It combines with the oxygen of the metal oxide to give out carbon monoxide. Thus, metal oxide is reduced to metal. For example, Fe2O3 plus 3C heated, then it will give iron. Okay, plus 3CO means carbon monoxide. Okay, now second example, ZnO, zinc oxide plus coke heat and it gives zinc plus carbon monoxide. Third example, SnO2 plus C, it will be heated again. Sn, it will give Sn plus CO, carbon monoxide. The main point is smelting. Sometime the question is rising, what do you mean by smelting? The answer is the reduction of metal oxides by heating with coke is called smelting. Okay, is the easy definition. The reduction of metal oxides by heating with coke is called smelting. Now next, reduction by CO. CO means carbon monoxide, so also act as reducing agent and further reduce the metal oxide to metal. For example, Fe2O3 ferric oxide react with CO, carbon monoxide, heated again, it will give iron and carbon dioxide. Okay, now second example, ZnO plus CO, heat again, it will give zinc plus CO2, carbon dioxide. Okay, now reduction by heating along with aluminium. Oxides of some metals such as manganese oxide, MnO2, chromium oxide, Cr2O3 etc. cannot be satisfactorily reduced by heating with carbon. These oxides, however, can be easily reduced to their corresponding metals by heating with aluminium powder. Okay, thus aluminium is converted into aluminium oxide, while the metal oxide it reduces the metal. The reaction is highly exothermic. The heat evolved is so high that the metal is obtained in molten state. Okay, for example, 3MnO2 we have taken plus 4Al aluminium powder. Okay, react with aluminium powder, it will be heated again, then we find out manganese, melt manganese plus aluminium oxide. Again second example, we take chromium oxide, react with aluminium powder, then it will give chromium, it is also melt chromium, we find melt chromium and again aluminium oxide. Okay, in the similar way, when iron third oxide is heated with aluminium powder, okay, then the heat produced is so high that iron so obtained melts. Fe2O3 plus 2Al ignited 2Fe plus Al2O3. This reaction is thus used for welding the broken parts of iron machinery, railway tracks, grinder, okay, etc. The reaction is called thermite reaction. Okay, the reduction of metal oxide to metal using aluminium as the reducing agent is called aluminothermy. Sometimes ये questions put होता है कि what do you mean by aluminothermy? Then the answer will be the reduction of metal oxide to metal using aluminium as the reducing agent is called aluminothermy. Now next one is reduction by heat alone. copper, mercury, okay, etc., have low reactivity. Their oxides can be reduced to metal by the action of heat alone. As their most common ores are sulfide ore, thus in order to obtain the metal from these ore, the only step needed is roasting, that is heating the ore strongly in the presence of excess of air. Okay, for example, Sg, mercuric sulfide, react with air, oxygen, heat, again heat it, then it will give mercuric oxide plus sulfur dioxide. Mercuric oxide again heat it, then it will give mercury plus oxygen. Now next and last topic of reduction, electrolysis, reduction by electrolysis. When sodium chloride melt, it is split into sodium ion and chlorine ion. We know that na, sodium is a plus ion, positive ion, the chlorine having negative ion. Okay, when electricity pass through the melt sodium ion go to the cathode while chlorine ion go to the anode. At the cathode, sodium ion gains electron and hence reduced to sodium atom, while chlorine ion lose electrons at the anode and hence get oxide to chlorine atom. These chlorine atom then react with each other to produce chlorine gas. Now this reduction topic has completed. In next video we will discuss roasting and refining and another process. Till then, have a good day.